Hi everyone. Now we are trying to combine two different features to one project, and that is to get the data from the ultrasonic sensor and that data to be displayed on the LCD. The data from the sensor is to be processed by the microcontroller and the information is to be displayed as the output by the LCD. In short, we are trying to get the data by the sensor and display by LCD. The LCD will display the measurement of the distance of an object placed in front of ultrasonic sensor. In my previous video, I have described the complete procedure how to connect the LCD with Arduino and how to get the output as a display on the LCD. Now we are going to install the ultrasonic sensor on the same LCD installed board, and in this video I will show you how to make the connections on the same LCD installed board. With LCD connections and how to get the data from the ultrasonic sensor, how to process the data with the help of this microcontroller, and how the processed information is to be displayed on the LCD. The objective of this project is to display the measured distance of an object on LCD. Now we are making the connections of ultrasonic sensor HCSR04. First of all, we have to install this sensor to the board. Now as we install this sensor to the board, we have to make the power connections. First of all, we will connect the positive pin to the VCC, that is the pin number 1 of Arduino, that is VCC. Now it's time to connect the ground pin, that is pin number 4 of sensor to the ground of Arduino. Now we have made the power connections. Now we have to make the data receiving and data sending connections, that is pin number 2, that is trigger, and pin number 3, that is echo of the this ultrasonic sensor. Now we have to connect the pins to the pin number 8 and 9. First of all, the trigger pin, that is pin number 2 Arduino, that is to be connected to the pin number 8 of Arduino. Now the pin number 3, that is the echo pin of ultrasonic sensor. And that is to be connected with the pin number 9 of Arduino. Now the trigger pin, the white one, that is pin number 2 to be connected to the pin number 8 of Arduino, that is going to receive the signals as an input. input signals. Then the echo pin, that is pin number 3, to be connected with the Arduino pin number 9, that will send the signals as output from sensor. Now we have made all the connections, LCD to Arduino and sensor to Arduino. Module work on the principle of sonar and radar system. It can be used to determine distance of an object range from 2 cm to 400 cm. When a pulse of 10 mu per second or more is given to the trigger pin, 8 pulses of 40 kHz are generated. After the echo pin is made high by the control circuit in the module, echo pin remains high till it gets echo signal of the transmitted pulses back. Now the coding part. First of all, we are including this liquid crystal.h file. Then trigger pin, that is pin number 8. Then echo pin, that is pin number 9. Long, that is the duration, or float, that is the distance. These are used for calculation for the distance. Now this is the code for LCD. RS registered pin 12, enable pin 11, D4 data 5, D5 data 4, D6 3, D7 2. These are Arduino pins 11, 12, 5, 4, and these are the pins for LCD. RS is for register pin of the LCD. EN is for enable pin for LCD, that is pin number 4, and that is pin number 6 of LCD. D4 is pin number 11, D5 is pin number 12, then 13, then 14. And this is the function that we have called from this particular library, and these are the parameters that we have given the values over here. Now void setup, the starting function LCD begins 16 into 2 means 16 column 2 rows. LCD print hello IoT, that is the message we have to print at the starting of the program. Then pin mode, trigger pin, that is pin number 8, and what we need output, because we have to send the signal. Then pin mode 2 is echo pin input. Echo pin is pin number 9, that will get the data from the sensor. Then serial begin. Serial means we want this output at this serial monitor. Okay. First, to check whether the signals are coming back or not. Then this loop function, cursors at 0, 1 position, first row 0 column. This is row 1 and 0 column. Then LCD print in milliseconds, there is a delay of 1000. Digital write, trigger pin low. Milliseconds is already mentioned in this your LCD library. Then digital write, trigger pin high, delay 10, trigger pin low after 10 nanoseconds. Then the pulse in that will be generated by this sensor, and the echo pin will get high to create the pulse. Duration into that will come to the duration, this complete pulse and the data. Then distance, we have to calculate distance, this duration into 0.34 divided by 2. That is a technical term of your this sensor. Now serial print that will be going to print on distance, and our LCD will also print this IoT 220 distance in centimeter and the actual distance.